Hello and welcome. Today, we're diving deep, quite literally, into the Earth's subsurface. The world of geophysical exploration, how we see beneath the ground, is undergoing a major shakeup. Driven by new tech and growing needs for resources and environmental checks, we're getting better, faster, and often cheaper ways to understand what lies beneath our feet. One huge leap is in sensor technology. Imagine using standard fiber-optic cables, sometimes miles long, as thousands of tiny seismic sensors. That's distributed acoustic sensing, or DAS. By shooting lasers down the fiber and analyzing the returning light, scientists can measure tiny ground movements caused by seismic waves or even fluid flow. It's great for tough environments and gives us high-res data for things like monitoring reservoirs, detecting tiny earthquakes, checking pipelines, and even watching for landslides or thawing permafrost. Sometimes, existing communication cables can even be reused. Then there are drones, or UAVs. They're changing the game for data collection. Drones can fly low, reach tricky spots, and carry sensors for magnetic, gravity, electromagnetic, and even ground-penetrating radar surveys. They bridge the gap between ground surveys and expensive plane-based ones, making detailed mapping more affordable and accessible. There is ongoing work to make drone sensors smaller and batteries last longer. With all this new data, how do we handle it? That's where artificial intelligence and machine learning step in. These tools are brilliant at spotting hidden patterns in massive datasets, automating tasks, and making interpretations more accurate. Think about cleaning up noisy seismic data, automatically identifying geological faults, building complex subsurface models, or even predicting where to find minerals or energy resources. I can sift through information much faster than humans, helping us make sense of the complex underground world. Processing this data avalanche and running complex simulations, like creating detailed 3D images of the subsurface, requires serious computing power. High-performance computing, often accessed via the cloud, is the answer. Cloud platforms offer scalable power on demand, meaning researchers can run huge calculations without needing massive data centers. It speeds things up and can even be more environmentally friendly, as providers often use renewable energy. It's not just about individual technologies but also about combining them. We're increasingly integrating data from seismic surveys, electromagnetic methods, gravity and magnetic measurements, along with geological knowledge. Putting all these pieces together gives a much clearer, more reliable picture of the subsurface. Even traditional methods are getting better, with higher resolution 3D and 4D seismic surveys and improved electromagnetic systems. Quantum sensors are also starting to appear, promising even better gravity and magnetic measurements. So, what's all this advanced tech used for? Well, yes, finding traditional resources like minerals and oil is still key. But it's also crucial for exploring geothermal energy potential, finding suitable sites for carbon capture and storage, managing our vital groundwater resources, monitoring environmental changes, ensuring infrastructure like dams and bridges are stable, and even exploring other planets. In short, next-generation geophysics is opening up a new window into the Earth. Through smarter sensors, powerful AI, cloud computing, and integrated approaches, we're gaining an unprecedented understanding of the subsurface, more accurately, efficiently, and sustainably than ever before. Thanks for tuning in.